So the first thing we're going to do here in this next chapter, which is all about functions and domain range and whether or not a relation is a function, is verify that we still remember how to graph on the coordinate plane. So here on the right, I have a coordinate plane. This is just a graph. We can see the x and y axis. It's a little bit, I wish it was a little bit more significant, but we see here, this is the x-axis. This up here, this vertical line is the y-axis. And it's asking us to plot all of these points to the left-hand side. So when you're plotting points, remember, the first ordered pair number you see is an x number, and the second number is the y number. So in order to plot these points, you're always doing two things. When you plot the x number, that is telling you where on the x-axis do you go to. So to plot the point 4, 8, on the x-axis, I would go over to the right to 4. 1, 2, 3, 4. And I don't make a point there because I have to follow the second thing it wants me to do, which is then go up 8 units. So 1, 2, 3, 4, 5, 6, 7, 8. And then you would make a point. This is where 4, 8 would be. It's asking us to label all of these points. So please label them by putting the point number that it is. This is point A, very close to where that point is. What I want you to do, please, is plot points B through J. I know that that's a lot. So 2, 3, 4, 5, 6, 7, 8, 9, and 10. You have to do all of these. So it's a lot of points, and it's a little tedious, but I know that this is pre-algebra material, so it shouldn't take that long. So I'll give you a few minutes to plot the rest of those points, and then we'll go over them. Yeah, we're going to go over all of these. Let's check with me one minute, okay? Are you guys done? Ben? Ian, are you done? William, are you done?
Yeah.
What do you guys want? Yeah. All right, so we're going to go over these to make sure that you remember how to plot points before we move on to anything more difficult than this. So letter B, -3, -1, we will go to the left 3 and down 1, and that's where this point would be. For C, we will go to the right 9 and down 5, and make a point here, and that would be point C. For point D, we'll go to the left 6 and up 7, and make a point here. For point E, you'll go to the left 5 and down 5. For point F, you'll go to the right 3 and down 1. For point G, you will go to the left 4 and up 4. For point H, you'll go to the right 2 and up 10. For point I, you would go to the left 3 and up 5. And then for the last one, J, you would go to the right 7, and you would not go up or down anything. You would just stay right there on the x-axis. So take a look at yours. Hopefully yours match mine here. And then it was asking us a second answer to use the graph to answer the following questions. So it's asking us to use a different graph, right? I'm going to have to erase this. So if I look at the next part here, using the graph below to answer the following questions, we now have the ordered pairs already written out for us, and we have to identify the coordinates to them. So looking at point A, you would look over here at the graph, and the first thing you would determine is where point A crosses the x-axis at. So you would look down to the x-axis and see that this is at -10. So point A, its x-coordinate is -10. So that's the first number you list. And then you look at the y-axis. On the y-axis, point A is at 12. So the y-coordinate would be 12. So the point A would be -10, 12. And then what I want you to do is fill out the rest of these points by finding out their x and y values for the rest of them here. And then it's asking which points are in quadrant 3. Don't forget that when we have a graph, we have 3 quadrants. The top right-hand quadrant is quadrant 1. They like to use Roman numerals instead of actual, just regular numbers like we're used to. Quadrant 2 is this top left-hand corner. Quadrant 3 is the bottom left. And quadrant 4 is the bottom right. So these are Roman numerals for 1, 2, 3, and 4, which will help you answer number 13 and number 12. And then number 14 is asking which of the 4 points creates a rectangle. 15 is asking which of the group of 3 points creates a line. So please take a couple more minutes and complete the rest of this page using this graph here. And then in a few minutes, we will go over the answers. So basically, what you're going to do is look at these points and you're going to find out what the ordered pairs would be over first because it's the x number first. All right, so we're going to go over these answers so that we can move on to the next part of our lesson today. Letter B, the ordered pair that represents this would be 8, 12, since it's over to the 8 units and up 12. Letter C would be negative 1, 8, since to get to letter C, you would go to the left 1 and then up 8. Letter D would be 0, 4, since you go left 0, you just stay right here on the y-axis and go up 4. Letter E would be 7, 4. Letter F would be negative 4, 0. Letter G would be 4, 0. Letter H would be 0, negative 4. Letter I is negative 12, negative 10. And letter J is 10, negative 13. All right, so here are all the different points and the ordered pairs that represent them. So it's asking for which points or just which point are in quadrant 3. So quadrant 3 is this quadrant down here. So we're looking at which points are actually in the quadrant. So what points are in that quadrant? Yes, it is just I. How come points F and H are not in quadrant 3? Right. F and H are both on the lines here, so they're not included in the quadrant. The only point would be point I. So that'll help us answer number 13. The points that are not located in the quadrant are all the points that are on the line, and that would be point F, H, and also D and G. All these points are on an x or y axis, which these 4 points are actually creating a rectangle as well, since they are all like 0, 4 or 0, negative 4. These 4 points here create a rectangle. So F, H, D, and G are the answer again because they create a rectangle. And what 3 points create a straight line? What?
A, C, and E.
Yes. What'd you say? G.
I said A, C, and E.
A, C, and E?
Yeah, they're doing a diagonal.
Yeah, so A, C, and E. Let me just verify that. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. Actually off by 1 little point. It's so close. A, C, and E are so close, but it's off by 1 little point.
Is it B, D, F?
H, G, E.
B, D, F. No, it's not that either, I don't think.
So is it?
H, G, E.
Yeah.
Yeah,
Last one.
it's H, G, E. These 3 points here create a line. To get from one point to the next, you would do the same exact thing. It's called slope. We'll learn about that later. But it's H, G, and E. All right, so moving on to some material that we have not seen yet this year, an introduction to functions. This might be brand new material. So we are now moving into definite 100% Algebra 1 material that you're going to have to memorize some new vocabulary words and learn some new things. So today we're going to be talking about relations and functions. A relation pairs inputs with outputs. Relations can be expressed as tables, graphs, mappings, and ordered pairs. Here's an example of a table. This table has an input x versus an output y. Tables are usually written like this, x first, then y. The table represents ordered pairs. The first ordered pair that's in the table is 2, 2.6. The next ordered pair would be 4, 5.2. And then 6, 7.8. That is considered a relation because it is ordered pairs in a table form. The next one is a graph. The graph has 3 points, 1, 2, 3. Every graph has ordered pairs, and every ordered pair is a relation. So this graph is a relation in graph form. This is a mapping diagram. This is something you probably have never seen before. Mapping diagrams are a way to show ordered pairs. The first ordered pair we have is that the input, which is x, is 1, and the output, which is y, is 8. So the first ordered pair we have is 1, 8. What would the second ordered pair be? Aiden?
2, that, 9.
Yep, 2, 9. And then what's the next one? Aiden?
3, 10.
Yep, 3.
And then 3, 11.
Exactly. Perfect. Thank you so much. So mapping diagrams show you what input is paired with what output, and you can create ordered pairs from these. Bless you. All of these examples are called relations. Relations are sometimes considered functions. So the next vocabulary word that we're going to talk about is a function. Functions are special types of relations where each input value is paired with exactly one output value. That means the x values do not repeat. Functions only occur if the x values do not repeat. Let's look at the first table here. The x values, the input, x, 2, 4, 6. Did any of these x values repeat? Nope, they're all different, which means this is a function. Looking at the graph, the ordered pair would be 1, 6, 2, 4, and 3, 2. The x values are 1, 2, and 3. Did any of those x values repeat? Nope, this is considered a function. Let's look at the mapping diagram. 1 to 8, 2 to 9, 3 to 10, 3 to 11. Did any of the x values repeat? Any of the x values repeat?
Yeah.
Yes,
3.
the 3. Because the 3 repeated and it pairs with two numbers here, because the 3 repeated and it's seen in two ordered pairs, this last example is not a function. Functions only occur when the x values do not repeat. So that last example is not a function. Here's an example, a real-life example of a vending machine. We can see here that this is a function because each letter and number combination is paired with exactly one food or drink item. So like A1 is only with this specific item. A2 is only with this specific item. If you ever repeat the same x value, then you would be considered not a function. So determining whether a function is a given set from a given set. Is this what you guys see next? Oh, no. So mine is a little bit off, and if you don't have the actual notes in the same order, yours is going to be off too. Let me scroll till I find what we're doing next. So here's what you see, right? Looks like this. So the last thing we're going to do today is just identify relations, functions, domains, and ranges. So, a review. A relation is between two variables, x and y, and it can be a set of ordered pairs. An ordered pair consists of x and y coordinates. And we already know from those notes that a relation can be viewed as ordered pairs, mapping tables, equations, or written in sentences. Here's something new. X values are called inputs. They're also called the domain. They're also independent variables, whereas y values are outputs, also known as the range, and they are dependent variables. So looking at example 1 is asking us for what the domain is and what the range is. So example 1 has a set of ordered pairs. To determine what the domain is and what the range is, what you would have to do is determine all of the numbers that are being represented in the input, which is x, and the output, which is y. So the domain is all of the x values. Looking at these ordered pairs, the x values are 0, 1, 2, 3, 4, and 5. The domain is a fancy way for saying x values. If you look here at this definition, x values are inputs, also known as the domain. So the domain, which are the x values, I can list them because these are all of the numbers in for x, and they are 0, 1, 2, 3, 4, and 5. You're supposed to always list these in order from least to greatest. The range is the next question. The range would be the y values. The range is all of the y values in the ordered pairs. So looking at the ordered pairs, it's -5, -4, -3, -2, -1, and 0. These are already in order from least to greatest, so I just have to copy them down. Your range are all of your y values. So here are the y values for that problem. This example is not asking us to determine this, but would this set of ordered pairs be a function? Look at the domain. Do any of the x values repeat? Yep. It what? Yep, this would be a function. Great. Looking at example 2, this is a mapping diagram. If this is confusing, then you could write out the ordered pairs if you don't like the way that this looks. Like 4 is being paired with -2, so the first one would be 4, -2. And then if you wanted to keep doing that, then -5 is being paired with -2. So you could write -5, -2. 0 is being paired with -2. 0 is also being paired with 7. 9 is being paired with 7. And -1 is being paired with 7. So if you prefer to see it in ordered pair form, you can do that and just rewrite them. But if you don't mind seeing it the way that it is, that's fine too. The domain is all of the x values. So you could just look at the input, which is the domain, and just write these numbers down, and that would be the answer. You just have to actually put them in order from least to greatest. The smallest number is -5, then -1, then 0, then 4, then 9. And the range is only 2 numbers. The only numbers in the in the y spot are -2 and 7, so that would be your range. Looking at this example, I can see that there are certain numbers that repeat. 0 repeats in the x spot 2 times. It's here and here. Because of that, this would not be a function. So we already went over if it's a function or not. So again, according to the textbook, a function is a relation in which every input is paired with one output. And if you have different x coordinates that never repeat, that is a function. If you have any x coordinates that do repeat, it is not a function. So looking at these last examples, and then we'll call it a day, we're looking to see whether this is a function or not by looking at these ordered pairs. So take a look at example 3, 4, 5, and 6. All you need to do is look at the inputs. 0, 1, 2, 3, 4, 5. Is this a function? So is this a function?
Yeah.
Yes, this is a function because none of the x values repeat. Example 4. I'm looking at only the x values. Is example 4 a function?
No.
No. What number repeats?
0.
Exactly. Right here, the zeros repeat, and you cannot have 2 of the same x values. Not a function. So let's write no. Example 5. Choice 1, it says which mapping represents a function. It's 3 to -1, 1 to 2, and 0 to 2. Choice 2 is 2 to 2, -1 to 3, -1 to -2, and 3 to 0. Which one is the function?
1.
Yes, the first one, because the second one, it repeats right here. And then this last example is asking which one represents the function. 2 to A, 2 to B, 2 to C, or A to 2, B to 2, C to 2. Which one does not repeat the same x value?
B.
Correct. This one does represent a function because all of the x values are different. I know that's a little bit weird with having variables as your x and y, but that is correct. All right, just because we have a couple more minutes, the last thing we're going to do today is look at the vertical line test. So we're going to skip example 7 for now and just visit this real quick. The vertical line test shows us in graph form if relations are functions. A relation is a function if a vertical line drawn through its graph passes through only one point. This is also known as the pencil test. Take a pencil and move it from left to right, and if it crosses through more than one point, it is not a function. So looking at these two pictures here, the vertical line test says take a pencil, right here's a picture of a pencil, and put it vertically like this, and then scan the graph from left to right. The vertical line test says if you only cross through one point each time you move the pencil to a different point in the graph, that means means it is a function. So looking at this here, would this line be a function?
Yeah.
Yes. Because anytime you're taking your pencil and moving it from left to right, you will only cross through one point on every vertical line that you make because this is just a straight line. Looking at this though, this is an oval. If I take my pencil and I move it from left to right through this graph here, would this be a function?
No.
No, because when you pass through different points, vertical lines, you'll pass through more than one point because this here is a circle, so you'll pass through more than one, which makes this not a function. Okay?